The second part of tonight's homework is just a review on some different concepts that we've worked in the past. The first concept is actually going to ask you to graph the line, but we're going to do the second concept, which says, without graphing, tell whether the point of the graph is on the given line. Now, this is a type of problem where a lot of people just look at it and they said, oh, I have to write an equation that's perpendicular to this line that goes through this point. No, they're asking us something different. They're asking us to tell whether the point is on the graph. So is the point on the graph? Well, what we're going to do is we're going to use just substitution. We're going to take our x value and put that in place of x. We're going to put the y value in place of y. So again, you got to read those directions carefully. Tell whether the point is on the graph. That's when you just substitute. So if you just substitute, you've got your answer. If they equal, you say yes. If they don't, you say no. Let's try it. Negative 4 times by the x value, which is 1, plus 2 times by the y value, which is 6. If it equals 8, we say yes, that point is on the line. If it's no, then it doesn't equal 8. Well, we do the work here. Negative 4 plus 12. We see if that equals 8. Sure enough, those two numbers do agree. So we say yes, that point is on the line. So on this next week's test, you're going to have the same question. I think the first problem is going to ask whether a point's on a line. And this is what you do, is just substitute. Now there's another example. Take this negative 1. This is our x value. And you just take that and put that in place of x in that equation. You take the y value, negative 6, that goes in place of y. You see if it equals or not. So we go ahead and do that substitution. We've got this, 5 times by negative 1 minus 3 times by negative 6. Should equal 14 if it's on the line. So let's see if it does. We do that multiplication here. One negative makes a negative, so we've got negative 5. Two negatives make a positive, so we got plus 18. Watch those signs. Negative and a negative make that positive. Well, if it equals 14, it's a yes, but we got a problem. It's one number shy. Those are not the same number, so we'd say no, that point is not on that line. Well, one more example here of that type. All you're going to do on this one, again, is just take your x value, take your 9, and put that in place of x right there. Take the y, negative 2 in that case, put that in place of y. And then rewrite what you've got. So here's what it is. It's a 1/3 times by 9. Now I'm going to write 9 as a fraction. 9 over 1 minus 2 times by, and then I've got that negative 2. And then it should equal 7. If it does, again, we say yes. If it doesn't, we say no. So let's see if it does. Well, 3 goes into 9 3 times. So I'm going to multiply those numbers, and I end up with a 3. Negative 2, negative 2, those multiply to make a positive 4. And they should equal 7. Well, it definitely does in this case. Those two numbers do agree. And so we say yes, 9 negative 2 is on the line defined by the equation 1/3 x minus 2y equals 7. Well, some more example problems. These are good ones for reviewing for that test. So your problem on your homework tonight, number 2, I believe it is a little bit easier than these. These require some extra steps to be able to graph, at least using the slope-intercept form. So let's take a look at this first one. 2y equals 3x minus 4. I want to get y by itself. It's easy to get y by itself here. All I have to do is divide by 2. And if I do that, I get the equation in slope-intercept form. So now I've got y by itself. I can rewrite this as y equals, and then I've got 3/2 x minus 2. So 3/2 x minus 2. And from there, we can graph this because we've got our y-intercept. Our y-intercept is down 2 spaces. So we go down 2 spaces and put a dot there. And then we use the slope. So again, all that slope is just following what it says, 3 to 2. So that means you're going to go from this point up 1, 2, 3, and then over 2. 1, 2. And then you put a dot. Do that again, up 3 over 2. Put a dot, up 3 over 2. And we're going over to the right. Now notice that slope is always consistent. That's the great thing about lines. The y-intercept, the rate of change, is always the same. Well, we could go the other way. We could go down 3, 1, 2, 3, over 2 to the left. And that's about all I can fit on the line. So from there we can draw a line between those points. And we've got it, just like that. Well, here's another example. Now this is one where you might use a different method. See, here I would end up using xy intercepts. So remember, for that x-intercept, you're going to want to set y equal to 0. So that will just cancel out that y term. And so when you do that, look what's left over. 3x equals 6. So that's what I'm going to write down over here. Just write down 3x equals 6. And then if I divide by 3, I'll have my x-intercept. Now this is not the slope, this is the x-intercept. So divide by 3, I've got x equals 2. So I go over on the x-axis, 2 spaces, and put a dot. Alright, that's the x-intercept. Let's take a look at the next one. Here, I can find the y-intercept by setting x equal to 0. So the y-intercept, I'm going to set x equal to 0. So I just cross that term out, and all I'm left with is that negative 1/2 y equals 6. So I can get rid of that by using, well, just multiplying by the reciprocal. So I'm going to multiply by negative 2 in this case, times by negative 2 on both sides. And when I do that, I end up with a y equals negative 12. Ooh, man, I don't know if I can go down that far. It's going to be way down here. So far, I might not even be able to fit it down there. So way down at y at negative 12. And then from there, you can just draw a line between those points. It'll be a very steep line. Well, one more example here. Let's take a look at this one. Here we need to, this is a good one to get y by itself by using division. And then just using the slope-intercept form to graph. So I could divide by 3 on all sides. Now when I do that, what I've got is y by itself now, and it equals negative 2/3 x plus 2. So from there I can follow what the y-intercept and the slope tell me to do. I can go ahead and go up 2 spaces, put a dot, and then use the slope. So the slope of this line is negative 2 to 3. So I said the slope was negative 2 to 3. So what we're going to end up doing is going down 2 spaces and then over 3 to the right. I could do that again, down 2 spaces, 3 to the right. I could also go the other way. I could go up 2 spaces and then 3 to the left. And that gets me on that same line. Up 2, 3 to the left. That gets me on that same line. And then from there, we can draw that line between all those points. And we'd have it. The equation in slope-intercept form allows us to draw lots of points to make that graph. Well, that's an example of tonight's homework.